IEC and NEMA are two dominant sets of electrical equipment standards. IEC equipment generally has a smaller and more compact size compared to NEMA equipment. IEC uses metric measurements, while NEMA uses imperial measurements. IEC equipment typically has a lower maximum power handling capacity compared to NEMA equipment. IEC equipment is designed for use in 50 Hz or 60 Hz, 220 to 240 volt systems. NEMA equipment is designed for 60 Hz, 110 to 120 volts or 208 to 240 volt systems. IEC equipment is generally considered to be less durable than NEMA equipment. NEMA equipment is designed to withstand more extreme conditions such as high temperatures and vibrations. IEC equipment is certified by conformity assessment bodies that comply with European standards. NEMA equipment is certified by Underwriters Laboratories, or UL, and the American National Standards Institute, or ANSI. Advantages of IEC equipment include its compact size, wider voltage and frequency compatibility, and potential cost savings. Advantages of NEMA equipment include high power handling capacity, greater durability, and that it is more widely available in North America. For further reading on the differences between IEC and NEMA electrical standards, you could look at articles that explain the differences. You could also investigate articles on IEC versus NEMA industrial plugs and sockets. You can find information from the National Electrical Manufacturers Association on standards and specifications. Also consider IEC 60309.2, which describes plugs, socket outlets, and couplers for industrial purposes. When considering IEC versus NEMA equipment, firstly consider the size and form factor. IEC equipment is often chosen where space is a constraint. Its compact design allows for integration into smaller control panels and machinery. Secondly, consider the power handling requirements. If your application demands high power, NEMA equipment is generally more suitable due to its robust design and higher power handling capacity. Thirdly, examine the voltage and frequency compatibility. IEC equipment is designed to operate with a wider range of voltages and frequencies, making it adaptable to different power systems around the world. NEMA equipment is primarily designed for North American power systems. Fourthly, assess the durability requirements. For harsh environments with extreme temperatures or vibrations, NEMA equipment offers greater durability and reliability. Fifthly, ensure compliance with relevant certifications. IEC equipment complies with European standards, while NEMA equipment is certified by UL and ANSI for North American applications. Another key difference is in the design philosophy. NEMA standards often prioritize robustness and overload capacity, whereas IEC standards may focus on efficiency and standardization. This difference stems from the historical context and the specific needs of the industries they serve. North American industries have traditionally favored equipment that can withstand demanding conditions, while European industries have emphasized energy efficiency and global compatibility. Consider motor control centers. NEMA motor control centers, or MCCs, are typically larger and more heavily constructed than their IEC counterparts. NEMA MCC are designed to handle high fault currents and provide enhanced protection for motors. IEC MCCs, on the other hand, are more compact and may offer advanced features such as communication capabilities for integration into automation systems. Another area of divergence is in wiring practices. NEMA standards often specify thicker wire gauges and more robust insulation materials to ensure reliable performance in demanding environments. IEC standards may allow for smaller wire gauges and different insulation types, reflecting the different electrical codes and practices in Europe. A choice between IEC and NEMA equipment can also depend on the specific application. For example, in the oil and gas industry, where equipment is often exposed to hazardous conditions, NEMA-rated equipment is generally preferred due to its rugged construction and ability to withstand extreme temperatures and corrosive substances. In contrast, in the renewable energy sector, where efficiency and grid integration are paramount, IEC-compliant equipment may be favored for its compatibility with international standards and advanced control features. The selection of appropriate equipment depends on a number of factors, including the electrical code, available space, operating environment, and power quality. It's essential to conduct a thorough assessment of these factors before making a decision. Additionally, consider the long-term maintenance and replacement costs. While IEC equipment may offer initial cost savings, NEMA equipment may have a longer lifespan and require less frequent maintenance, resulting in low total cost of ownership. One critical aspect to consider is the impact on personnel safety. Both IEC and NEMA standards incorporate safety requirements, but the specific approaches may differ. NEMA standards often emphasize physical protection and grounding, while IEC standards may focus on insulation and electronic protection. Ensure that the selected equipment meets the applicable safety standards and that personnel are properly trained to operate and maintain the equipment safely. Also think about the availability of spare parts and service support. NEMA equipment is generally more readily available in North America, while IEC equipment may require longer lead times and specialized service expertise. Consider the implications for downtime and maintenance costs when making your decision. Choice between IEC and NEMA equipment can also have implications for system integration. NEMA-rated equipment may be more easily integrated into existing North American systems, while IEC-compliant equipment may be better suited for international projects or systems that require compatibility with European standards. Carefully consider the compatibility and interoperability of the selected equipment with other components in the system. Another important factor to consider is the level of expertise available. Engineers and technicians familiar with NEMA standards may find it easier to work with NEMA-rated equipment, while those trained in IEC standards may prefer IEC-compliant equipment. Consider the skills and experience of your team when making your decision. The choice between IEC and NEMA equipment is not always straightforward and may require careful evaluation of various factors. By understanding the key differences between these standards and considering the specific needs of your application, you can make an informed decision that optimizes performance, reliability, and safety.